Bright QT. Every student matters.
Recall that two circles are congruent if their radii are same. It is obvious. Circle has got one parameter only, that is its radius, right? If we take the center at any point on the plane and we know the radius, right, and we get another circle at any point on the plane and it has got same radius, right, then these two circles are congruent. What it means, that if I pick one circle and place it on other, it will completely overlap it, and vice versa. The other one, if I pick and place it on this one, it will also overlap it completely. That is, their boundaries will overlap each other completely. Okay, so obviously these are congruent circles if they have same radii. So the first part is okay. Prove that equal chords of congruent circles subtend equal angles at their centers. So first thing, we know that their radii are equal. Now we take equal chords. Let us take AB here and CD here. So AB is given equal to CD, okay, and if I join it with O here and let it be O dash, so O dash C, O dash D, and it is given that they have same radii. So this is, if this is R, this will also be R, this will also be R, and this will be R. Now look at triangle AOB and triangle COD. AB is equal to CD, equal chords, right? OA is equal to O dash C, OB is equal to O dash D. Why? Because congruent circles have same radii, right? Now by side congruence criterion, I can say triangle AOB is congruent to triangle COD. And now by CPCT, I can talk about these angles at the center. That is this angle, if let us say this is theta and this is alpha. So I can say theta is equal to alpha by CPCT. If you don't want to write it theta or alpha, you can say angle AOB is equal to angle COD by the same reason, CPCT. Corresponding parts of congruent triangles are equal. So yes, if we have got two congruent circles, then the angles subtended by equal arcs at their centers are equal. Okay. Prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. Now this question is just the converse of previous question. In this question, we will consider that the angles subtended at the centers of congruent circles are equal. That is this angle, and we get a congruent circle, that is circle of equal radius. So if this is R, this will be R, and this circle is congruent to this circle, so the radius here will be R. Let it be O, this is O dash. So this is AB, this is CD. Okay, and theta is equal to alpha because the angle subtended by these two arcs are equal. So what is given? OA is equal to OC, OB is equal to OD, angle theta is equal to angle alpha, because these are equal angles at their center. Okay. Now, given these three facts, I can say by side angle side congruence criterion or rule, I can say triangle AOB is congruent to triangle COD. Hence, AB is equal to CD by CPCT. So you can easily observe, if you are clear with your triangles chapter, then these observations are very, very obvious. Okay, you can clearly see that these things are equal. If these two angles are equal, then these chords will also be equal in case of two congruent circles. So yes, AB will be equal to CD. Now it is proved that if chords of congruent circles subtend equal angles at the centers, then the chords are equal. Okay. So this was about this lecture here. In the next lecture, we will discuss about other aspects of circle. Okay. Thank you.